Hello, welcome to Coordinate Geometry. I'm Daniel Chen, and I will be going over Section 2.2 of your Math Resource Guide. So let's start with what is coordinate geometry. So coordinate geometry is analysis of shapes, lines, and other graphs on a plane with quantifiable positions. We have topics including midpoints and slope, functions and the distance formula, circles, spheres, parallel and perpendicular lines, vectors and planar geo, as well as quadrilaterals. The first thing we'll go over is midpoints. To find the midpoints of 2 points, we average each of their x and y components. For example, if we have the points x1, y1, and x2, y2, these two will combine to find the midpoint of x1 plus x2 over 2 and y1 plus y2 over 2. This would be the midpoint of points x1, y1, and point x2, y2. Now let's take a look at the example. So let's say we have 2 points, -4, -5, and 2, 7. Now, how do we find the midpoint? Just by looking at this graph, we can see that the midpoint is about at -1, 1. However, let's look at this from a mathematical perspective. Mathematically, we can see that -4, -5, and 2 and 7 combine to form -4 plus 2 over 2 and -5 plus 7 over 2. Simplified, this goes to -1, 1. So as you can see, this formula works. Now let's look at an example. We are given the points -8, 2, 3, and 4, -6, 7. What is the midpoint of the line segment connecting these 2 points? Now, I know there are 3 digits in the coordinates, but that simply means that it's in 3 dimensions. The same formula still applies. So we continue and we notice that the 2 points combine to form -8 plus 2 plus 4 over 2, 2 plus -6 over 2, and 3 plus 7 over 2, simplifying into -2, -2, 5. Now I apologize for not providing a graph, but graphing in 3D is very hard. So as you can see, this works in as many dimensions as you want. You can bring this up to 4 numbers in the coordinate. You can even bring it up to 5, although I wouldn't see the practicality of that since you couldn't even graph it. Now looking at slope. So slope is typically calculated as delta y over delta x, meaning change in y over change in x. An easy way to remember this is rise over run, as we'll see here. So we have this line here. To find the slope, we first look at its rise, which is 8, and then its run, which is 12. Rise being going up and run being going horizontal. So rise over run, this line has slope of 8 over 12, which simplified becomes 2 over 3. Looking at another example, this line has a rise of -5 and a run of 7. So the slope would be -5 over 7 or -5 over 7. What is the slope between the points 5, 7 and -3, 10? This time we're only given the points. We're not given a graph or a line to look at. Well, here we use an important formula. So from this we can see that the rise is -3 and the run is 8. So it's -3 over 8. However, what you notice is that the slope is also equal to 7 minus 10 over 5 minus -3. So this leads us to the conclusion that with points x1, y1 and point x2, y2, the slope between these 2 points will be y1 minus y2 over x1 minus x2. This is an important formula to remember. Now, let's get into a bit of functions. Functions are important in graphing. So, functions are equations that relate y in terms of x. The y is typically denoted as f of x to demonstrate that the function is taken in terms of x. So, here's an example. This is a function f of x equals x squared. There are many of these functions like this, and they are important to remember, so keep in mind of this one. We'll go over a few more functions to remember, the first one being x cubed. The next one, e to the x. And the final one is square root of x. These three functions are good to keep in your mind, even if it's not used in the decathlon. So, we're finally at the distance formula. The distance formula calculates the distance between 2 points. This formula works in both 2 and 3 dimensions. So as you can see, for a 2-dimensional with points x1 and y1 and point x2 and y2, we have the distance is equal to the square root of x2 minus x1 bracket squared plus y2 minus y1 bracket squared. From third dimensional perspective, we still square everything and square root. However, we have 3 variables this time instead of 2, as you can see in the formula below. So, as you can see, an easy way to remember is the first goes with the first, the second goes with the second. As for this one, the first goes with the first, the second goes with the second, and the third goes with the third. This way you don't mix them up and mess up the formula. So, let's try this example. Find the distance between the points 1, 3, 2 and 5, negative 7, 2. So, here is our relationships. Keep it in mind. So, our formula would be 5 minus 1 squared plus negative 7 minus 3 squared plus 2 minus 2 squared. This translates to square root of 4 squared plus negative 10 squared plus 0 squared. Now you notice that all the numbers inside the square root will have to be positive, since you're squaring every single number inside. So once you add these up, you get square root of 116, which also translates to 6 square root 3. Circles and spheres are essentially the same, except one being 2-dimensional and the other being 3-dimensional. A circle or sphere is defined as the entire set of points that are a fixed distance, radius, away from a center. The diameter is defined as twice that of the radius. So circles and spheres have the following equations that define them. A circle has the formula x minus h squared plus y minus k squared equals r squared. Does this look a little familiar? Well, it's just another form of the distance formula. So for a sphere, similar to the distance formula, you have 3 variables except everything is still squared. So the centers that these will have, well, the circle will have hk as a center, and the sphere will have abc as a center. These both have radius r, so the radius will always be squared. Let's look at an example. What is the equation for a circle centered at 4, negative 5 with a radius of 3? Well, let's look at our formula. Our formula is x minus h squared plus y minus k squared equals r squared, with the center hk being 4, negative 5 and the radius being 3. This translates to the equation x minus 4 squared plus y minus negative 5 squared equals 3 squared, which translates to x minus 4 squared plus y plus 5 squared equals 9. As we can see down below, there is a graph of the circle. Here is a second example. It's not exactly finding the equation. However, if the diameter of a circle has endpoints 1, 2, and 5, negative 6, then find the center point of the circle. If you imagine the diameter of a circle being twice that of the radius, we know that the center of the circle will just be the center point of the diameter. So, the center will be equal to 1 plus 5 over 2 and 2 plus negative 6 over 2, translating into 3 negative 2. So, this is a clever implementation of the midpoint formula. Next, let's look at parallel lines. Parallel lines are defined as having the exact same slope. So as we can see, we have 2 functions here, f of x equals 2x plus 2 and f of x equals 2x minus 4. As we can see, the slopes are exactly the same in these 2 equations. So the slope of the red line, that's how you determine the slope of a line, which is the number next to the x. And then the slope of the blue line is also 2. So these 2 lines are parallel. Now let's look at perpendicular lines. So perpendicular lines are perpendicular if their slopes are negative reciprocal of each other. meaning that in this case, m1 is equal to negative 1 over m1. As an example, we can see that f of x, these two functions, f of x equals 2x plus 2, and f of x equals negative 1/2 x minus 4, these two form a right angle. And as you can see, the two slopes are negative reciprocals of each other. So, one thing to note is that in 3 dimensions, there are an infinite number of perpendiculars to any given line. So, any line in 3 dimensions has an infinite number of perpendicular lines to it. Let's quickly look at vectors, which the resource guide calls movements. I don't know why. So, vectors are a measure of direction and movement, not only movement. So a vector of AB means that it is pointing in the direction of AB in the two-dimensional plane. For example, we have this vector, which is a vector of 1, 3. As we can see, the x direction is going 1 unit to the right, and for the y direction is going 3 units up. And that is pointing in a certain direction. So vectors are typically represented by line segments topped with an arrow. However, I didn't draw an arrow in this one. If you have a line with direction ABC and then define the perpendicular directions as x, y, z, then ax plus by plus cz equals 0. This brings us back to the point that any line in 3 dimensions would have an infinite number of perpendicular lines to it, since the equation ax plus by plus cz has an infinite number of solutions of a, b, and c. So let's look at quadrilaterals. There are 4 key strategies when approaching quadrilateral problems. Find the slope of sides, find the slope of diagonals, find the length of sides, find the length of diagonals. For strategies 1 and 2, you need to use the slope formula, and for strategies 3 and 4, you need to use the distance formula. So these are quadrilaterals and their properties. You can identify quadrilaterals by using their slopes and their distances and comparing them to their properties. A square would have perpendicular sides with equal side lengths. It would also have perpendicular diagonals with equal diagonals, and it would have parallel sides. So that is just one example. There are also many others, like the isosceles trapezoid and the rhombus. The isosceles trapezoid doesn't have perpendicular sides, nor does it have equal sides. It only has one pair of equal sides. It doesn't have perpendicular diagonals, and its diagonals are equal. However, it doesn't have 2 pairs of parallel sides. Only one pair of its sides are parallel. Here's another last quadrilateral. It's called a kite. A kite doesn't have perpendicular sides. However, 2 pairs of its adjacent sides are equal. It also has perpendicular diagonals. However, their diagonals are not equal to each other. It doesn't have parallel sides at all. Thank you for listening. See ya.